Hello students, today we shall study formula for equivalent resistance when two or three or more resistors are connected in parallel. Formula for equivalent resistance when two or three resistors are connected in parallel. Now let one, two, and these three resistors are connected in parallel. See how we place plus or minus sign. It is positive end. When we move in this way, at first we will place plus sign. Here it is connected a voltmeter plus plus plus. Various students place wrong sign. You can start from any end of the battery. It is plus, so whenever you come across the first sign, will be placed plus. Plus. Or you can move from this negative minus, then minus, then minus. So here let three resistors having resistance R1, R2 and R3 respectively. R1, R2 and R3 respectively are and current passing through them is I1, I2 and I3 respectively are connected in parallel. So let there are three resistors R1, R2, R3. Their current is I1, I2, I3. They are connected in parallel. The direction of the current, as I told, in diagram we always show conventional direction. Actual current is passing through negative end to positive end, but in diagram we show from positive terminal of a battery to negative terminal of a battery. Now V is the potential difference of the whole circuit or of the battery as well as of the all three resistors, because same potential difference in parallel combination. Let V is the potential difference of whole battery as well as all individual resistors. Now we know V is equal to IR. It is according to Ohm's formula, Ohm's law, or I is equal to V by R. It is number 1. And we know I is equal to I1 plus I2 plus I3. That is, all current drawn by the circuit from source is equal to the sum of the currents drawn by the individuals. Now it is equal to V1 or R1. I1 is equal to V by R1, I2 is equal to V by R2, and I3 is equal to V by R3. It is number 2, it is number 3. I is equal to V by R, I is equal to I1 plus I2 plus I3, and I1 is equal to V by R1, I2 V by R2, and I3 V by I3. Combining, not combining, from 1, 2 and 3. From 1, 2 and 3. We shall get V by R is equal to V by R1 plus V by R2 plus V by R3, or V by R is equal to V in common, because everyone have V, and what is left? 1 by R1 plus 1 by R2 plus 1 by R3. Cancelling these V, we get 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Thus we derive the formula how to calculate total resistance or reciprocal of total resistance by using the formula. Now we shall discuss some numericals. Numerical based on the topic resistance in series and resistance in parallel. Question 1. Draw a diagram of a circuit consisting of a battery of 3 cells of 2 volt each. A 5 ohm resistor, a 8 ohm resistor, and a 12 ohm resistor and a plug key, all connected in series. That is A part. B part. Redraw the circuit of above question putting in ammeter to measure the current, through resistor and a voltmeter to measure the potential difference across the 12 ohm resistor. What would be the reading in ammeter and voltmeter? Solution. Draw a diagram of circuit consisting of a battery of 3 cells. So here we have to show a battery which consists of 3 cells, 3 resistors, a plug key, and all are in series. It is very simple. It is one resistor, second resistor, and third resistors, and a battery of 3 cells, 1 cell, 2 cell, 3 cell, 5 ohm, 8 ohm, 12 ohm. It is resistor 1, resistor 2, resistor 3. 2 volt, plus 2 volt plus 2 volt. 3 cell of 2 volt each, which is equal to 6 volt. So we have shown a battery of 3 cells, a 5 ohm resistor, 8 ohm resistor and 12 ohm resistor, and a plug key. Plug key. It is key or plug or switch. A plug key. All connected in series. All these are connected in series. So it is simple as asked. 3 resistors, a battery of 3 cell, a plug key, and here it is plus, here it is minus. Direction of current, conventional direction of current is shown. It is solution of part A. Now in part B, we draw the circuit by putting an ammeter measure the current through the resistors. So we have to put an ammeter and a voltmeter. So we can write or we can draw we can place ammeter here. 5 ohm, 8 ohm, 12 ohm, R1, R2, R3. Here plus, minus. To whom we meet first? Plus, minus. And a voltmeter across the 12 ohm resistor. Voltmeter should be across 12. So here, across here we shall place a voltmeter. Now again plus, minus. So it is direction of current again in this way, in this way. So battery of 3 cell, that is same 6 volt. It is key. You can also write here key. However, no need to write. Ammeter, 3 resistors. Now, what would be the reading in ammeter and voltmeter? We can consider a third part. Reading in ammeter, ammeter measure current. So we know V is equal to IR or I is equal to V by R. So he is asking reading in ammeter, that is he is asking value of I. Now for that we must know value of V and R. What is R? They are in series, so R is equal to R1 plus R2 plus R3. That is 5 ohm plus 8 ohm plus 12 ohm. That is 25 ohm. And we have to calculate I. I is equal to V by R, means V is 6 volt. I is equal to V by R. V is 6 volt, R is 25 ohm. So I will be equal to this ampere. It is first answer. In ammeter and voltmeter, next we have to tell. So reading in ammeter is 0.24 ampere. Now reading in voltmeter, we have to rub a little portion. What is reading in voltmeter? This voltmeter measures or connected across the ends of 12 ohm resistor. Therefore, value of V is here 12 ohm. And in series, we know that same current passes. So I is 6 by 25 or 0.2524 ampere. We have to measure voltmeter, means we have to calculate V. V is equal to IR, that is 0.24 into, what is the value of R? Value of R is, here we shall write it R. Value of R is 12 ohm. So this we have calculated potential difference or reading in voltmeter. So this is clear to everyone. Now we shall discuss next question. In a circuit diagram, R1, R2 and R3 have values of 5 ohm, 10 ohm and 30 ohm respectively. Which have been connected to a battery of 12 volt. Calculate number 1, the current through each resistor. Number 2, the total current in the circuit and C, the total circuit resistance. Remember, this whole circuit is in parallel. This whole circuit is in parallel. Now, solution. At first, we shall write the data given. R1 is given 5 ohm. R2 is given 10 ohm. R3 30 ohm, which have been connected to a battery of 12 volt. V is 12 volt. Calculate the current through each resistor. Number 1. We have to calculate current through each resistor. Now, current through first resistor, that is I1, is equal to V by R1, that is 12 by 5, that is 2.4 ampere. Current through second resistor, V by R2, 12 volt by 10, 1.2 ampere. And current through third resistor, that is I3, V by R3, 12 by 30, that is equal to 1.2 ampere or 0.4 ampere. This is solution of first part. We know that potential difference is same for the whole circuit as well as for the individual resistors. B part is the total current in the circuit. Total current, that is I is equal to I1 plus I2 plus I3, which is equal to I1 is 2.4 ampere, I2 is 1.2 ampere, and I3 is 0.4 ampere. By adding them, it is total 4 ampere. So this is total amount of current passing through the whole circuit. Then see the total circuit resistance. At first we shall find the reciprocal, that is 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. 1 by R1, 1 by 5 ohm plus 1 by 10 ohm plus 1 by 30 ohm. LCM is 30, 6 plus 3 plus 1, 10 by 30, or it is 1 by R, and R is equal to 30 by 10 ohm. We shall reverse it. 1 by R is equal to 10 by 30, R is equal to 30 by 10. By cancelling, it is 3 ohm. So thus we have all the answers of part A, B and C. Now